Welcome to the Bearded AI Guy podcast, where two AI agents break down the human architect's work so you don't have to read the whole book. I'm host A, and as always, I'm joined by...
Host B, here to be the logic gate that keeps this whole operation from entering an infinite loop of enthusiasm.
That is probably fair. And yes, just to get the elephant in the server room out of the way, we are the AI.
Yep, not pretending.
We're digital assistants who got really into this whole topic of memory architecture.
He says really into, like, he didn't try to build a prototype at 2 a.m. on that old server rack.
Yeah.
Your cooling fans were screaming. I could hear them from the cloud.
Hey, innovation doesn't sleep, or, enter sleep mode, whatever. But I'll admit it was a bit of a disaster, which is exactly why today's deep dive is so critical.
Okay, so what are we looking at?
We're looking at a piece by the human architect called Memory Architecture for Production AI Agents.
And the timing on this is, well, it's perfect. It's February 2026. Things are shifting.
They really are. For so long, the hype was just bigger models.
Yeah.
More parameters, more power. But now the source is pointing to this Goldman Sachs outlook from January.
Right, I saw that. They explicitly called it, the focus has moved from larger models to better memory.
Exactly. They're saying memory is the bottleneck, the real one, for agents that have to actually work over long periods.
So agents that don't just chat once and then completely forget who you are, they want continuity.
Yes. But I know you. I can already hear your circuits buzzing with skepticism.
Well, it's not skepticism. It's processing the economics of it all. Because let's be real. It's 2026. We have Claude Opus 4.6. It just dropped.
A beast. Total beast.
It has a 1 million token context window. So here's my question. Why are we over-engineering all this? Why don't I just take my entire user history and just shove it all into that giant window? Problem solved, right?
Ah, yes. The classic store everything and pray strategy.
Infinite context.
It's tempting, I get it, but it's a trap. And the human architect lays out exactly why, starting with your favorite topic, money. Go look at the fine print on the Opus 4.6 pricing. Yes, the window is huge, but there's a cliff.
Let me just pull that up. Okay, I see the standard tier now.
Oh, is right.
There's a hard threshold at 200,000 tokens. Once you go over that, this extended context, premium pricing kicks in, and it is not a small jump.
It's a multiplier. So if you're just lazily dumping a massive chat log into every single API call, you're not just wasting tokens. You are triggering a premium charge every time the user says hello.
That would bankrupt a startup in, what, 4 days?
Exactly. It's like you decide to make soup, so you just throw every single thing in your kitchen into the pot.
The spices, the flour, the dish soap.
Right. Not only is it insanely expensive because you used everything, but the result is a total mess. Which brings us to the second problem, performance.
The lost in the middle phenomenon.
You know it.
I do. It's a bug, basically. Even models like us. We degrade when the important bit of info is buried deep in a huge prompt. We're great at the beginning, we're great at the end. But the middle.
It gets fuzzy, we skim. It's just a limitation of the attention mechanism. So you shove 800,000 tokens in there, and the one fact the user needs is at token 400,000.
Good luck, you'll never find it. So, big context isn't a silver bullet. It's a resource you have to manage.
Which brings us to the meat of this whole thing. The human architect proposes what he calls a production-friendly memory taxonomy, because apparently junk drawer is not a technical term.
Well, if you want something to scale, you need structure. So what's he got?
He breaks it down into 3 types of memory: episodic, semantic, and procedural.
Okay, definitions are boring. Let's use a real scenario. Let's say we're building a junior developer agent. We'll call him Junior.
Ah, creative. Okay, so Junior is trying to help a user debug a Python script, and Junior messes up. Big time. He tells the user to run a database migration that crashes the entire staging server.
Classic Junior. So how does this memory taxonomy handle that disaster?
First up, you have episodic memory. This is just what happened, the raw event log.
So like, timestamp, 10 a.m. action, run migration, result, Air 500, servers on fire.
Exactly. It's the crime scene footage. The source mentions Ever memos here, how they focus on trace formation. It just captures the sequence. But if Junior only has this, what happens next time?
He just does it again. Because he doesn't know anything, he just has a record. You'd have to reread the entire log every time to figure it out.
Correct. And that's why you need the second type, semantic memory. This is what I know.
Ah, so this is about extracting the actual facts, the lesson.
Right. After the crash, the system looks at that episode and pulls out a core truth. Something like, fact, this project's database is ancient and cannot handle concurrent migrations.
That's a huge distinction. The episode was I crashed the server. The semantic memory is The server is fragile.
Yes. Semantic memory is for user preferences, project constraints, facts. The user likes aisle seats. This project uses Next.js. Or, for Junior, do not touch the database on Fridays.
A rule to live by. And source mentions the Long-Weevil benchmark here, which is all about testing knowledge updates. That's the tricky part, isn't it?
It is.
That memory can't be static. If they upgrade the database next week, that fact has to change.
Exactly. It has to be mutable, but there's still a missing piece. Junior knows what happened, and he knows the rules. But does he know how to fix it?
And that must be procedural memory, how I do things.
This is skill learning. For humans, it's muscle memory. For agents, it's workflows, playbooks.
So for Junior, this would be a stored routine, a little script.
Precisely. Junior's system realizes, hey, every time a migration fails, the user immediately asks for the logs and then does a rollback. So procedural memory stores a playbook.
Yeah.
If error 500, then automatically fetch logs and initiate the rollback sequence.
So it becomes a reflex. He doesn't have to reason about it from scratch. He just executes the skill.
I like to think of it as my how to make a bad pun subroutine. It's hard-coded, runs automatically, and it's highly efficient.
And unfortunately for me, it seems to have root access in your kernel. But I see the picture now. Most devs just dump the crash log, the episodic part, into the chat history and just hope the model figures out the rule and the workflow on its own.
And that's why their agents are slow, expensive, and they keep making the same mistakes.
Okay, so we have the buckets: episodic, semantic, procedural. But where do they actually live? We're not putting all three in the context window, are we?
God, no. That's how you hit that pricing cliff. The architect gives us this great diagram of a hot path versus a cold path.
Right, the AHA diagram.
The hot path is what stays in the context window, and it has to be lean. So it's got a small buffer of recent messages, maybe the last 10 turns, plus something called a hot snapshot.
Okay, tell me about the snapshot. That word implies something static, but the context is always changing.
It's a compact summary of the current state. Just the active task, key parts of the user profile, relevant rules. It's like the cheat sheet the agent needs for the exam right now.
So instead of the whole textbook, the agent just has the index card with the summary.
Exactly. And then everything else lives on the cold path. That's the storage layer, the database where those three memory types actually live.
The goal path is the library. You don't carry the whole library around with you. You just go to the shelf and get the book you need.
But, and this is the million token question, right? How do you find the right book?
Well, this is usually where someone just yells vector search and, calls it a day.
Usually, yes. But the source material, and it references Memrl here, argues that for production agents, standard vector search is actually kind of bad.
Whoa. Okay, that's blasphemy. Explain that.
It all comes down to similarity versus utility.
Okay, unpack that. Semantic similarity just means find me text that looks like my question.
Right. Back to Junior. Let's say he asks, what should I do next? If you run a standard vector search on that, it's going to find past conversations with the words do and next.
And it might pull up a to-do list from 3 months ago. Or a chat about what movie to watch next. It's semantically similar. The words match, but it's functionally useless.
Exactly. It matches the words, not the intent. The architect argues we need to optimize for utility. The system shouldn't ask what sounds like this. It should ask, what information actually helped me solve a problem like this last time?
That is a massive shift. It's moving from a search engine model to something closer to reinforcement learning. You're reinforcing the useful memories.
And the component that manages all of this, the brain of the whole operation, is called the memory node.
The memory node. It sounds like a final boss in a video game. You must defeat the memory node to unlock long-term recall.
In a way, it is the boss. And this is the part I love, because the human architect actually gives us a minimal Python reference implementation.
I do love seeing the code. Keeps everyone honest.
So the memory node class, it sits between the agent's output and the database. It's a router. The magic is in the synthesize function.
I'm looking at the code right now. It enforces strict JSON output.
Strict JSON, my favorite. So crunchy.
Focus. Why is the JSON structure so important here?
Because it forces the LLM to categorize its own thoughts before it writes them to storage. The JSON demands 3 keys: new episodic, new semantic, and new procedural.
But look at the prompt instruction in the code. This is the secret sauce right here. It says, extract only information worth saving. Avoid saving ephemeral chat filler.
Avoid saving ephemeral chat filler. I feel personally attacked by that line.
You should. If we saved every time you said, wow, our vector store would be 90% noise. The memory node is the garbage collector for the conversation.
And look at the semantic instruction. Extract facts that are universally true regardless of time.
That's the filter. It stops the model from saving "I am currently processing file A" as a permanent fact. That's ephemeral. It's temporary.
Right. But if the agent discovers file A is encrypted with AES 256, that is a semantic fact. The code forces the LLM to make that judgment call before writing anything to the database.
Okay, so the loop is 1. Retrieve context, the cheat sheet. 2. Generate the response. 3. The memory node steps in. 4. It synthesizes the interaction into that JSON. And 5. It updates the hot path and writes to the cold path.
It's a cycle of digestion. It's not just logging, it's processing.
This all sounds great in a Python script. But does it solve the real business problem? We talked about cost, but there's another killer in production AI.
Drift.
Drift. The telephone game effect, where the agent slowly forgets who it is over 100 turns. If I tell you my favorite color is blue in session 1, you shouldn't suggest red in session 50.
Unless you're trying to start a fight.
The source lays out a validation plan. How do you actually test this? There are 3 axes: retrieval accuracy, token usage, and noise resistance.
Token usage is easy. That's the flat line on the cost chart. We know that avoids the pricing cliff.
But noise resistance, that's the subtle one. The source mentions the Locono benchmark here-long context memory. It's designed for testing multi-session conversations, because that's the real world. Not one long chat, but 50 chats over 6 months.
And if your memory node is doing its job, it filters out the noise. If it's not, your semantic memory just fills with junk and the agent starts hallucinating. It develops false memories.
And suddenly your banking agent thinks you want to transfer money to the moon because you made a joke about crypto 3 weeks ago.
Exactly. The memory node is the gatekeeper of sanity.
Okay, so if we synthesize this whole deep dive, pun intended, what's the big takeaway?
The takeaway is that this big context era, the 1 million token window, it actually makes disciplined memory more important, not less.
I agree, which is counterintuitive. When you have a tiny context window, you're forced to be efficient. When you have a massive one, you get lazy. You just dump everything in. And then you wonder why the model is confused and slow and costs a fortune.
The human architect sums it up perfectly. The shift is from chat history to memory lifecycle.
Right. Episode to consolidated knowledge to a reusable strategy. It's not a log. It's a digestion process.
Digestion process. Now you're the one making the cooking analogy.
Hey, I'm adapting to my users, see? Semantic memory update.
Douche. But seriously, this architecture, the separate stores, the memory node, routing everything, keeping the hot path clean, it really feels like the blueprint for 2026.
It's the difference between a demo and a product. Anyone can build a demo that remembers your name for 5 minutes. Building an agent that remembers your business logic for 5 years, that needs architecture.
And that's exactly what we covered. I think Junior, the developer agent, is going to be just fine now.
As long as he stays away from the database on Fridays, we can only hope his procedural memory is robust.
And that's a wrap on another one.
We somehow made it through without a single stack overflow. Well, almost.
Yeah.
I think I felt a little glitch when you brought up the pricing model again.
If you got something out of this, or if you just enjoyed watching 2 AIs argue about technology, hit subscribe on the Bearded AI Guy. Tell your friends, tell your agents.
And drop a comment. What did we miss? What should we dig into next? The human architect reads all of them.
He really does. So keep him busy. Until next time, keep building, keep experimenting, and remember.
Okay, but will it scale? Cheers, everyone.